to really demonstrate the IP video. We're going to be doing this one by Skype because he had to go to the UK. So I'm going to see if I can pull this up. Give me a second here. And there he is. Tim, good morning. Can you hear us?
Yes, I can. Can you hear me okay?
Yes, I hear you just fine. So
Excellent.
yeah, I'm going to take you full screen. And the floor is yours. Welcome to Modern Technology.
Thank you very much. And good morning, everyone. I have to say that I'm disappointed that I'm not joining you for Bits on the Bay this year. Instead, I guess you could say I'm doing Bits with the Brits this week instead. And I'm quite sure it's not as picturesque here as it is where you all are, but I'm very pleased to have this opportunity to join you virtually and share Snell's perspective on the applicability of standard IP routing technology in the hybrid SDI IP broadcast environment. So just double checking, are you able to see the slides? You seeing the title slide?
Right now we see you, and I'm going to switch over to the slides. So
Okay.
now we see the slides. So I can.
Thanks.
You're good.
All right. Let's see if I can continue here. All right. When I talk with broadcasters such as yourselves about using IP technology for routing signals and control data, they usually talk about three potential benefits. The biggest appeal is increased operational flexibility and efficiency. The idea being that IP networks can be format agnostic and adaptable. They can be scaled up and down. They can be readily reconfigured. But additionally, IP networks can be used to carry all of your data traffic on one converged fabric, from file-based traffic to control data, messaging, live signal flow, both to and from facilities and within a facility, and all using that same infrastructure. There's also a sense that you could lower your costs, leveraging common off-the-shelf IT platforms, and thereby participating in cost economies of scale from the broader IT industry, and taking advantage of all the tools, techniques, and talent from the IT ecosystem. And I think there's also an understanding that all of these potential benefits are really fueled by the massive investment that goes into the IT industry and into IP networking technology in particular, an investment that really dwarfs our industry's ability to invest in broadcast-specific technologies like SDI. So while IP signal routing is very appealing, and there I just caught myself saying routing. I'm in the UK where everyone seems to say routing, and I'm an American, so I usually say routing, but you'll probably hear me mix it all together as I'm over here mixing my languages. In any case, while IP signal routing is very appealing, there are some open questions which I'll try to address in the presentation here. First question is whether IP networking can be as cost-effective as traditional SDI infrastructure. And one corollary there is whether you'll have to purchase a broadcast-specific IP switch instead of a standard IP switch from IT vendors like Cisco, Juniper, and Extreme. The second question is whether IP can be made practical. Can you do everything you're used to doing in the SDI realm and the IP domain? Will you be able to assemble solutions using products from different vendors, or will there be incompatibility headaches? And what will the switching costs look like for you? No pun intended. Will you have to redesign your workflows and retrain your staff accordingly? So that's a big open question. And I think the last question is really about timing. When will it be feasible to start using IP signal routing alongside or in addition to traditional SDI routing infrastructure? So I'm going to try to tackle each of these questions over the course of the presentation, but to really get into that analysis, I think it's helpful to compare the core technologies of SDI signal routing and IP data switching. And I think we're all familiar with SDI, and SDI router sits at the heart of a facility and takes care of moving signals wherever they need to go. Essentially, SDI routers are defined by the number of SDI ports they offer. Each port supports one signal in real time and in one direction only, and the cost of an SDI router scales directly with the number of ports. So more ports means more cross points in architecture and more cost overall in the hardware. STI routers can connect with one another and share a common control layer, but typically they're deployed in a monolithic, centralized approach. And with STI routing, one of the cool things is that the sources and destinations are usually co-timed, so the router can actually understand the signals and manipulate the content as it flows through the router. So a Snell router like the one depicted here can do all kinds of signal processing in the core, manipulating the signals in real time, not just routing them from one source to a destination. And because all those signals are aligned in time to a common sync reference, you get clean switching for free really throughout the system. An IP switch, though, if you think of it as a signal router, it's a very different animal entirely. An IP switch is defined really by bandwidth, not by ports. The number of ports attached to the switch can be scaled independently from the bandwidth, so you can have a high bandwidth switch with a small number of ports, a lower bandwidth switch with a lot of ports, and unlike SDI, those ports and the cables connected to them can carry multiple streams of data at once, multiple streams of video and audio, and bidirectionally as well. So when you're buying a switch, you need to model the aggregate bandwidth that the switch is going to have to handle, and that will really be the predominant factor in determining the cost of the switch. Another difference is that IP networks support highly distributed topologies like the internet, and because all the data is packetized, the switch itself is really unaware of the types of data that might be passing through it. And this means that the IP switch can't understand or interpret the content as easily. In one sense, this means that a standard IP core is less powerful because it can't process the signals the way an SDI router can, but it also makes the system overall more flexible because it's data agnostic. An IP switch doesn't know if the video passing through it is SD, HD, 4K, 8K. It doesn't know whether it's 420 or 422. It just focuses on moving the packets where they need to go as efficiently as possible. And this means that in an IP-based broadcast system, the edge devices need to be smarter if the core is not as capable of transforming the content. So, for example, edge devices won't always receive carefully code-timed signals, so each edge device is going to need to know how to recover synchronization by looking at timestamps within the data streams. And you also don't get clean switching for free anymore. You have to be thoughtful about when and where you need clean switching and implement it in the appropriate edge devices. So IP is a very different way of thinking about moving signals around when you compare it to SDI. We have done some high-level cost comparisons that I'd like to share with you. You could do these yourself, but in any case, when you buy a broadcast-capable SDI router, the cost per signal or port, think of it as roughly $300. Could be a little more, could be a little less. But when you compare it to an IP switch, you need to calculate, oops, I think I switched slides there. Yeah, but to compare it to an IP switch, you need to calculate the cost per unit bandwidth, which would be roughly $100 per megabit per second. And for a comparable IP switch, you can see that the cost per unit bandwidth is already a lot lower, roughly half, at, call it roughly $50 per megabit per second. And that price point is dropping much more quickly for IP technology than for SDI. But it's not just about the bandwidth. The edge devices need to be IP enabled. So you need to factor in the cost of IP interfaces. And if you're going to use compression, you need to factor in some additional cost for that compute capability at each edge device. But even when you factor in sort of how you would burden each of the edge devices to be smarter, IP offers significantly lower costs. And we've seen that you can drive those costs lower by using light compression. Where you decide to use heavier compression, the cost of burdening the edge devices with more compute power starts to offset some of that cost savings. But even then, with heavier compression, we believe the cost per signal is at least comparable to SDI and generally lower than SDI. And as I said before, trending down very quickly. So that's the cost equation. I'd like to just take a second to talk about codecs. Like any vendor in this space, we've evaluated a variety of codecs, and we expect the baseline, as we've seen with SDI, the baseline for IP may still be uncompressed for interoperability. But for different applications, you may decide to use light or heavy compression. And there are a lot of codecs out there to choose from. There's a large number of H.264 variants. There's JPEG 2000, TICO. One codec we think is kind of interesting is VC2, which is a SMPTE standard that was originally developed by the BBC as DRAC. And when you look at the attributes of a codec and what would be good for routing signals within a facility, we think VC2 makes sense because it's very high quality, but it's also very low complexity, making it relatively inexpensive to implement. It was also designed to survive multiple encode-decode iterations without signal degradation or without significant signal degradation. And because it's unencumbered by intellectual property rights, it's royalty-free, which is appealing. That said, we're not wedded to any one codec, and as much as we'd like to see the whole industry converge on a small number of codec variants, we are pragmatically implementing a broad range of codecs so our customers can continue to choose different approaches for different applications. So without trying to do a complete tutorial on IP routing, it's probably worth briefly noting that there are a number of IP technologies we can leverage in the broadcast space. Unicast is a simple point-to-point routing approach, and if 3 destinations need to receive a signal, you have to basically make 3 copies of each data packet and send them on their way. When you introduce multicast, those 3 destinations can simply join a multicast group and receive the same signal, even though it's only been sent once by the source. So you can see how with multiple signals passing through each cable bidirectionally, and with approaches like multicast, the overall system can be made much more efficient at scale. And using technologies like source-specific multicast, we have found that you can accomplish very low latency routing across a distributed fabric. I think there's a lot of concern and sensitivity around the issue of latency, but in our development work and proofs of concept, it's actually been in some cases, difficult to measure the latency. So we've had very good results. Multicast, as I said before, I think also allows you to effectively segment the traffic within your IP network. So we can do things with IP technologies that emulate SDI concepts, SDI routing concepts like multi-matrix. And we've also found that by extending our existing router control protocol, we can implement capabilities like source and destination interrogation. And I think you've probably seen a number of different demonstrations of clean switching at the edge in the destination devices. And so with things like PTP timestamping, we think that clean switching is not only possible, but fairly easy to implement at the edge. All right, so stepping back from the specifics of the technologies, you can start to imagine a hybrid SDI IP topology that gradually evolves around a distributed IP fabric, connecting IP-enabled edge devices. And for those of you who didn't go to NAB last month, you would have seen announcements and product launches from vendors like Snell that fall into roughly 2 categories. The first category being IP-enabled SDI gear. So you'd have seen traditional SDI routers, production switchers, modular hardware, playout devices, encoders, decoders, multi-viewers, all that stuff, sprouting IP interfaces so they can now talk both SDI and IP. And the second category of announcements you would have seen is IP native gear. And in some cases, that's just presented as software that runs on COTS hardware with just an IP interface and no SDI capability. But all of these devices sort of connecting and coexisting on a common fabric. We actually demonstrated at the Snell booth a hybrid SDI IP workflow And we were able to show a variety of IP-enabled equipment and native IP equipment connected around a standard Cisco switch. And I think it was pretty interesting. We had a variety of sources and destinations. We were able to connect IP-enabled and IP-native signal processors. And we were able to control all of this through a standard broadcast router control panel. And I'll just say that I showed this demonstration personally to many customers, and in some ways it's even more exciting on paper than it is in person, because you go up to a router control panel, you punch up a source and a destination, you take the route, and then the signal switches, and it's sort of something you've seen a million times before, and in that sense it's kind of uninteresting on the surface, but under the covers there's certainly a lot going on, and I think it shows that the industry is actually implementing IP and not just talking about it. Another factor is really that we were showing multi-vendor devices, a multi-vendor arrangement of devices, and I think you're seeing more and more of that at these demonstrations. So every trade show or every regional event, you'll see more and more interoperability. I guess the other point to make here, and I think John's going to probably delve into this in a few minutes, not only are there a number of codec choices in addition to uncompressed, there are also a number of standards that describe how to encapsulate signals, packetize them. So that's another area that we're looking forward to seeing some convergence over time. But in this proof of concept, we were showing a cross-section of different encapsulation methods. So you can see a list of some of them down in the bottom left, things like literal translation of SDI into IP using 2022-6, but also elemental streams packetized. And so I think there's, again, a diversity of codecs and techniques for packetizing audio, video, and control data. And really, we're just starting to see the convergence in the next months and years around, I hope, a small set of widely implemented standards. So I guess in terms of functionality, in our development efforts and our proof of concept projects have really shown that it's possible to provide all the functionality that you expect from the SDI realm in the IP domain. So from our perspective, it's not really a matter of if, it's more a matter of when. And the transition from SDI to IP has been a topic of debate and prognostication for many years. But at Snell, we believe there's now ample evidence that the future is imminent, a future when you'll be able to flexibly integrate a diversity of media facilities and operations around a standard IP MPLS core sourced from standard IT vendors. And in this way, IP will enable distributed operations. We think it's also suitable for applications within a facility or at a remote site where we've traditionally seen SDI. And for that reason, we're placing a lot of resources into IP enabling our products and creating new IP native products as well. So I guess in summary, looking back at the questions I posed at the beginning of the presentation, our product development work at Snell and cost modeling also show that IP networking can be more cost effective than SDI today, and we believe that differential will become even more favorable going forward. I think if there's one message I can leave you with, it's that you should be wary of anyone who says you'll need to buy broadcast-specific IP switches. And I hope the subtlety of this message is not lost on you, because Snell is a purveyor of fantastic SDI routers, and those routers now support IP interfaces in the router frame itself, but we're not going to build an IP switch. We believe broadcasters should build IP-based workflows on standard IT technology, and therefore take advantage of the whole technology stack and the cost economies of scale there. In our proof of concepts, we've shown that IP routing can be practical, and we hope it proves to be reliable. I think that's sort of the stage that we're in now, is exploring that dimension. And we think that IP will provide you with more flexibility than SDI. We've demonstrated that IP routing can provide functional parity with SDI, and we believe it can be made interoperable across vendor implementations. The work we've done with other vendors has shown us that it is possible, and the standards do help to drive that kind of convergence. I think that, again, it's not always that thrilling to demonstrate IP routing. And in that sense, we've shown that it can be made transparent to broadcast operations. You shouldn't know when you're at the panel there whether you're routing IP to STI, STI to IP, et cetera. Those permutations should all look and act the same way in your production workflows. And then last, in terms of the timing of it, I mean, there's certainly been decades of investment in STI, so the industry is not going to cut over to IP on a knife's edge. But I think the presentations today and the momentum building at NAB show that the vendor community is doing more than just talking about IP. We're now releasing commercial products that support IP. So we're now seeing this overall transition unfold, first with hybrid STI IP infrastructure and complemented by native IP solutions as well. So with that, I'd like to say thank you. It's a very exciting time to be in the industry, and I hope you're hearing similar themes and perspectives from other vendors and industry leaders over the course of yesterday and today. I'm going to stay on the line if possible for the other presentations and for Q&A, but I've also put my contact information on the screen, and I certainly encourage you to follow up with me if you have any questions or feedback. So thank you very much.
Thank you very much, Tim. Thank you. So our next presentation is John Milho from Imagine.